How to design a blockchain state registry. Now let's have a look at how to design applications on Bitcoin-like systems to address the discussed situations. The practical difference between Turing-complete Ethereum-like systems and non-Turing-complete Bitcoin-like systems is that in Ethereum, you can design a smart contract in which some third party can commit transactions unconditionally or under some conditions. In Bitcoin-like systems, it is impossible to do such things with cryptocurrency. Crypto in such a blockchain is a holy grail of private property. But the trick is that we are not talking about cryptocurrency. This is about blockchain-based tokens and their applications. And it appears nothing limits the design of such an application, which can provide access to a third party to a user's digital asset, and hence make it applicable in real legal applications. For example, let's take a title token, a digital record representing property rights on land, and our usual actors, Alice, Bob, and the rest of the alphabet. The principal design of the system is the following. There are two elements, a blockchain and an overlay database. Let's make it even more interesting. Two blockchains, two independent blockchain networks, which we bundle so users can choose which blockchain they use to transfer assets, and they can also transfer assets between the chains. This will ensure market competition of technologies. Besides, I promised on this channel to elaborate on the cross-blockchain protocol. So here it is in action. Entries are published on either blockchain and then added to the database on top. In the design of our application, we ensure that only transactions of our clients, of our users, get to this database. Besides, the app ensures that these transactions are compliant with our rules. To ensure consistency of the database, we don't want to have duplicate tokens which belong to different users, don't we? Before publishing an entry to the blockchain, we check it against this database. In other words, a user before creating a token asks this database whether it already contains such a token. If someone decides not to ask the database but publish the same token, we remember that blockchain nodes don't care what you add in your coin spending transaction. They just ensure that there is no double spending with cryptocurrency. So our system on top still will ignore an incompatible and non-compliant entry and will not add it to the database. This is a short explanation of the database on blockchain. All non-Turing complete platforms work this way, even though it seems that such platforms look like a holistic solution. If you dissect them, you will find at least two major components: the blockchain with its consensus protocol and a superstructure on top, a program that contains a database and algorithms that allow to create and manage digital assets. The pure blockchain consensus protocol has nothing to do with such applications, but blockchain applications rely on the protocol as it ensures that blockchain as a data storage is immutable and chronological, and the nodes have the same copy of the ledger. In many blockchain applications, it is possible to publish non-compliant entries, or so to say, to publish whatever you want in the coin spending transaction. Nodes independently decide what they include in blocks. It just must be compliant with their consensus protocol, say proof of work or proof of stake, and so on. That protects from double spending of cryptocurrency and ensures synchronization of nodes, that they have the same copy of the blockchain. So we can say that such platforms have this second layer of consensus, a social one, a convention that lets them act the same way around this database. Even if one node decides to accept a non-compliant entry, such an entry will be published on blockchain, but because of such a convention, other nodes will not add this entry on top. Hence will not show the users it as a legitimate asset. This way works a lot of blockchain platforms: NEM and Symbol, NXT, Ardor, Waves, Cardano, before the introduction of smart contracts in 2021, and many others. In our case, the social contract will extend across two ledgers. We can say that for our overlay system, these ledgers play the role of reliable and immutable repositories that prevent corruption of the database on top. If a user accidentally deletes her database or it gets corrupt, she still has the blockchain. To restore this database, the user needs to scan the blocks from the beginning. As a result, she will get the same database. More so, all the users or any user will independently get identical databases because they scan the same blockchain, applying the same protocol to the entries. We can say that the blockchain is a kind of log subsystem with append-only transactions, while the application is a dynamic superstructure that reflects the current state of affairs in the blockchain. The system on top scans all transactions in both ledgers and checks whether they contain compliant entries. How does the system recognize entries of our land registry application? Well, those users who want to create title tokens in this registry system must add flag bytes at the beginning of their entry. When the hook, in some blockchain platforms it is called so. So when the hook on top recognizes this combination of bytes in any transaction, it understands that the entry must be retrieved and parsed. If it complies with our registry application rules, the entry will be published in the database on top. For non-developers, I should clarify that when I say something like the user adds flag bytes, surely the end user does nothing, your application does it, as it is designed to. How to create digital assets? Here we apply the basic rules of a database that contains primary keys and values. The land title has its ID. In different countries it is called in different ways: a cadastral number, a folio number, or a parcel number. It doesn't matter. One thing matters for this system: it's a unique string that identifies the asset. This is fundamental for our system. If we allow Alice and Bob to be owners of records with the same ID, or database-wise speaking, with entries that contain the same primary keys, it will break the whole logic of the registry, as we won't be able to distinguish who owns what. So let's form the token entry. ID, a unique cadastral number, and attached values or fields. Geographical positions, at least 3 points is needed to form a figure. Surely it can be more than 3. So we can identify the land plot. In further videos about land registry systems, I will explain how to ensure that land plots do not overlap. Alternatively, we can add an IPFS hash address to store geodata off-chain. Who owns it? The user's address, which is a representation of the user's public key. As the rule, we define that the owner is the one who published this entry. And the force field will contain a hash as an anchor of data about this land plot. We need to store something about this property, but its volume is too large to add it on blockchain, and it's not so critical to secure it on chain. Remember that the volume on blockchain is constrained. You can watch this video if you don't know what hashing and anchoring on blockchain is. And the last field of our entry will contain a reference to another token entry. Let's call it certificate token. So this field contains a reference to another entry in our database. I'll get to it soon. We might need to add more fields. And at this point I have to say that for a real land register, we'll need more comprehensive application. This is just a simple implementation to demonstrate the principal design of a cross-chain application. Besides, if you're looking for a solution to tokenize other types of property and rights, and to create not just any tokens, but tokens for legal applications, you can use the proposed application architecture as a reference. But each time when I use the word land, you can replace it with cars, boats, patents, corporate rights, a flock of sheep, or whatever you need, as the issues we are addressing here enable legal transactions with any rights. When I say land authority, you can replace it with any private third party who can become a trusted intermediary, or replace it with third parties with different roles: auditors and lawyers who would certify some facts, arbitrators who would resolve disputes, and so on. Now let Alice create a record of her land rights by publishing a digital token on blockchain. She adds data according to the entry format discussed above. Then her wallet checks if the primary key of her entry corresponds with an existing primary key in the database. If someone has already published an entry with the same key, her wallet will notify her and will not let her publish it. If it's unique, meaning that nobody has such a token yet, her wallet forms a coin-spending transaction, wraps the entry in it, and shares it in the network mempool. Other nodes see the transaction in the mempool and can add it to a block. Once a node creates a block that contains Alice's transaction among numerous other transactions which are irrelevant for our application. But we know that a lot of people can publish whatever they want, can commit any transactions because it's just a public blockchain. But anyway, her wallet picks exactly this transaction because it contains the flag bytes that indicates that her wallet must pick such a transaction in the database. As you might remember from our video about blockchain databases and my video jurisdiction on blockchain, find the link to it in the description. Users who want to see this token have to apply the same protocol, or simply put, to use the application that Alice uses, as the same application being applied on top of any blockchain node will give the same result on any node. Therefore, we can say this protocol is a kind of filter that users mutually agree to apply to the whole totality of transactions in the blockchain. Once applied according to the agreed parameters, all users independently see the same database on their local machines.